The first quiz of this unit covered similar figures and scale drawings, and you had to be able to do 4 different things relating to similar figures and scale drawings. So the first one was finding the scale factor. The second one was finding a missing side given 2 similar figures. The third thing was finding the model or the actual given the scale. And then the fourth thing was actually to find the scale. So we're just going to quickly go through each 4 of these things just to kind of refresh, and then you're going to do quiz corrections. So when you're finding the scale factor is the ratio of corresponding sides in a figure. And we always find scale factor by using the new length over the original length. And remember, you have to use corresponding sides, and corresponding just means same place. So if we look at triangle ABC and triangle DEF, AB is in the same spot as DE, and then BC is in the same spot as EF. So if we look at number 1, it says to find the scale factor from A to B. So if we're going from A to B, this triangle A is the one that I'm starting with, so that's my original. Triangle B is my new one. So if I have to use N over O, which is new over original, I can use any side that I want, but I just have to make sure that the other side that I use is corresponding. So if I look at triangle B, if I use this side right here, which is 5, that means I have to use this side right here, which is 15. And remember, figures are similar if they're the same shape but a different size. It doesn't matter which way they're oriented. So they don't have to be in the same place. Like this one is upside down, or it's flipped over. So if I use new and old, I have to put my new length on top. So 5 over 15, and that simplifies to 1/3. So my scale factor is 1/3. Number 2 says find the scale factor from triangle SUT to triangle PRQ. So remember, this right here is a similarity statement. So it says triangle PRQ, so the small one is similar to triangle SUT, which means they're the same shape, just a different size. And we can also use the similarity statement to tell us, in this picture it's obvious which sides are corresponding, but I could use a similarity statement to know for sure. So PR is in the same spot as SU, so this side and this side are in the same place. RQ is in the same spot as UT, so RQ is in the bottom, it's in the same spot as UT, which is in the bottom on the other one. And then this one and this one, so PQ is in the same spot as ST, so that's my longest side of that triangle. Okay, and then again, it doesn't matter which length I use because I have all 3 lengths, but I do have to figure out which one's my new, which one's my original. So if I'm going from triangle SUT, so the big one, to PRQ, that means I'm going this way. This one's my original because I'm starting with SUT, this one's my new. So if I use this one, this length, and I can use these 2 because they're in the same spot on the triangles, new over old, 8 over 12, and then that simplifies to 2/3. So my scale factor is 2/3. And that's all you have to remember for scale factor is new over original. Okay, so then when you find missing side measures, you can either use a scale factor or you can set up a proportion. I think setting up a proportion is easier. So again, you have to be able to realize which sides are corresponding because you have to use 2 pairs of corresponding sides to set up our proportion. So I always start with X, and then I look to see, okay, on my other triangle, where is X? So 11.25 is the side that's corresponding to X. So I'm going to put X over 11.25, and then it doesn't matter what other side I use as long as I'm using 2 corresponding sides. So I can use 8 and 6. So if I put X on top on the left, I have to make sure I'm putting whatever other side length that I'm using from this triangle with X on the top of the other one. and then 6. Then I can just solve the proportion. So 8 times 11.25 is 90, and then x times 6 is 6x. Now this is just a one-step equation. So 6 times x, how do I undo that to get x by itself? I can divide. So then 90 divided by 6 is 15. So the missing side length is 15. Okay. Now the second one, it says given triangle CDE is similar to triangle FGH, find DE. So I'm going to start by saying, okay, I want to find DE, so I'm going to put an X there. Now I'm going to set up my ratio and then my proportion. So DE is corresponding to GH. I can use my similarity statement to tell me that. So X over 11 2/3 equals, I'm going to use CD and FG. So CD is right here, and then FG is right here. 8 on top of 13 1/3, and then I can cross multiply. So 8 times 11 2/3 is 93 1/3, and then x times 13 1/3 is 13 1/3 x, and then I can divide both sides by 13 1/3 to get x by itself, because I'm undoing the multiplication, and I get x is equal to 7. What's important to find the missing side is to use corresponding sides and set up a proportion. Okay, so when you're finding model or actual, of course we're working with scale drawings or models. They're proportional to each other. So we're always going to set up a proportion to solve for either the model or the actual. And like it shows here, this first ratio is always your scale, so it's always going to be given to you. It'll say like 1 inch is equal to 2 feet, and it can be written in any type of ratio. So you could use a colon, you could use an equal sign, you could use, it could be in a fraction. It could also say like 1 inch represents 2 feet. And then the other side of your proportion, so your other ratio, one space is going to be x and the other is going to be whatever is given to you. And you just have to figure out if it gives you your model or your actual. You can also use the units to match where it would go. So number 5 says the plans for a new street show lampposts that are 2.5 inches apart. If the plans use a scale of 1/2 inch equals 9 yards, find the actual distance between the lampposts. So there's 3 important things in this problem that we need. We know that the plans show street lampposts that are 2.5 inches apart. So I know if I'm talking about plans, that means it's my model, it's not actual. It also gives me my scale, which I need, and then it's asking me to find the actual. So my actual in this problem is going to be x. So I know I'm writing a proportion, and I know that the side on the left has to be my scale. And it says 1/2 of an inch is equal to 9 yards. Okay? Now I can go back to where it gave me my model. I know it's my model because it says it's plans. I also know that I want to match my units. So if inches is on top in the scale, that means inches is going to be on top on the right side of our proportion. I also know because model over actual, my model always goes on top. And then I'm looking for x yards. So I can just solve the proportion now. 2.5 times 9 is 22.5. So when I find my scale, every single time I'm finding my scale, I know I'm going to find my scale because it literally says find my scale or find the scale. Every single time you find a scale, you're going to write your ratio of model over actual. So remember, call your ma. and then you just divide the top and the bottom of the fraction by the top, because you want your numerator, which is the top of your fraction, to be 1. So number 7, it gives me my drawing and my actual. Drawing is another word for model. So 8 feet over 624 feet. Now, it doesn't matter that they're both feet. They can both be feet. They can be different units. It doesn't matter. Remember, I want my numerator to be 1. So how do I get my numerator to be 1? Divide by itself. And if I divide the top by 8, I have to divide the bottom by 8. So 8 divided by 8 is 1 foot. And then 624 divided by 8 is 78 feet. So my scale is 1 foot equals 78 feet. And I can leave that as a fraction. I can write it 1 foot colon 78 feet. I could say 1 foot equals 78 feet. There's multiple ways you can write it, but you have to be able to recognize when you have a scale. Okay, number 8 says, in a painting, the Great Pyramid of Giza is 45 centimeters tall. If the pyramid is actually 146.5 meters tall, find the scale. So it asks us to find the scale. That's how we know we're finding the scale. So model over actual. In a painting, it's 45 centimeters tall. A painting isn't real. So 45 centimeters. And then it says it's actually 146.5 meters. So I want to divide my numerator and my denominator by my numerator. So I want to divide the top and the bottom by the top number. 45 divided by 45 is 1 centimeter. And then 146 divided by 45 is approximately 3.256. But I don't have a calculator right now, so I would leave it as a fraction, but I can't because I don't know what the fraction is. So that would be my scale.